Chapter 13, Segment 1, pages 389 to 396. Touch. The term touch is used to refer to the sensations caused by the mechanical displacements of the skin. Tactile refers to these mechanical interactions and will expand the definition of the sensation of pain, which occurs when our body tissues are damaged in some way. Kinesthesia is the perception of the position and movement of our limbs in space. Proprioception is perception mediated by kinesthetic and internal receptors, which is Latin for one's own. Somatosensation is collectively sensory signals from the skin, muscles, tendons, joints, and internal receptors. Soma is the Greek word for body. Pain serves as a sophisticated warning system that tells us when something might be internally wrong or when an external stimulus might be dangerous, enabling us to defend our bodies as quickly as possible. Temperature sensations enable us to seek or create a thermally safe environment. Touch is important because we can use it to identify and manipulate objects that cannot be seen or heard. Touch receptors in the skin. The human sense of touch is mostly housed in what is actually the largest and heaviest of the sense organs, the skin, which covers an area of approximately 1.8 square meters and weighs about 4 kilograms. Also found within our mouth and our muscles, tendons, and joints. Epidermis is the outer of two major layers of skin. Dermis is the inner of two major layers of skin, consisting of nutritive and connective tissues, within which lie the mechanoreceptors. These receptors form the basis of multiple channel, specialized information processing subsystems that each contribute to the overall sense of touch. Each type of receptors can be characterized by three attributes. 1. Type of stimulation to which the receptors respond. 2. Size of the receptive field. And 3. Rate of adaptation, which is fast versus slow. Tactile receptors. There is the mechanoreceptors, which is a sensory receptor that responds to mechanical stimulation such as pressure, vibration, or movement. This consists of a nerve fiber and an associated expanded ended. A beta fiber, a wide diameter myelinated sensory nerve fiber that transmits signals from mechanical stimulation. Glabrous, in reference to the skin, is lacking hair. The nerve fibers of the various types of tactile receptors are assumed to terminate in different expanded endings. Meissner's corpuscle, a specialized nerve ending associated with fast adapting fibers that have small receptive fields. This is FA1. Market cell nucleus complex, a specialized nerve ending associated with slowly adapting fibers that have small receptive fields. This is SA1. Pacinian corpuscle, a specialized nerve ending associated with fast adapting fibers that have large receptive fields. This is FA2. And Ruffini ending, a specialized nerve ending associated with slowly adapting fibers that have large receptive fields. This is SA2. The ending of Meissner and Merkel receptors are located at the junction of the epidermis and the dermis, and the Pacinian and Ruffini receptors are embedded more deeply in the dermis and underlying tissue. The fiber of the tactile mechanoreceptor extends all the way from its terminal at the expanding end to the dorsal root of the spinal cord. The four mechanoreceptors are always working together to inform us about every object we touch. SA1 and FA1 fibers act similarly to cones and rods, and feeling the shape of your key in your pocket requires the SA1 channel. The SA2 channel is involved with shaping your fingers, and the FA1 channel is as you insert the key into the lock, your grip forces increase so that the key does not slip. And the FA2 channel tells you when the key has hit the end of the keyhole. Thermoreceptors, a sensory receptor that signals information about changes in skin temperature. There's warmth fiber, a sensory nerve fiber that fires when skin temperature increases. And then there's cold fibers, a sensory nerve fiber that fires when skin temperature decreases. There's C fibers, a narrow diameter, unmyelinated sensory nerve fiber that transmits pain and temperature signals. Then there's A delta fibers. It's a myelinated sensory nerve fiber that transmits pain and temperature signals. Our bodies are constantly working to regulate their internal temperature, so under normal conditions, the kind is kept between 30 degrees Celsius and 36 degrees Celsius, which is also 86 degrees Fahrenheit and 96 degrees Fahrenheit. Nociceptors is pain in the realm of touch that has the dubious honor of being home to the sensations we like least. Pain being with signals from nociceptors. Nociceptors is a sensory receptor that responds to painful inputs such as extreme heat or pressure. Touch receptors that have nerve endings and that respond to damaged tissue or stimuli that have potential to damage tissue. Lack specialized endings and can be divided into two types by their nerve fibers. Myelinated A delta fibers respond primarily to strong pressure heat, and unmyelinated C fibers respond to intense stimulation of various sorts, pressure, heat, or cold or noxious chemicals. Pleasant touch receptors, the C tactile afferent, which is known as the CT, a narrow diameter unmyelinated sensory nerve fiber that transmits signals from pleasant touch. The adaptation rate of CT fibers is intermediate between those of myelinated SA and FA mechanoreceptors.